All right, good morning, good morning, good morning. Hope all is well. Still see a few trying to connect, so let's give them a chance. All right, looks like everyone in who is coming in. Once again, good morning. Hope all is well. Hope everybody had a great weekend. Sorry for running a few minutes late. Hopefully, you saw my email. I had a little bit of a situation that I had to take care of, so put me a little bit behind. But glad you guys were able to stick it out with me. Hold on for a few minutes. So let's get these notes up. Any general questions before I go ahead and get to the notes? Today's notes. Everybody good? Straight? All right. All right. So last class we ended off with slopes. That is, what section is that for you guys? That's 10.4. So we'll look at 10.5 and 10.6 today. All right. So let's see here. So this is going to take us where we want to go. Parallel lines. Okay. Perpendicular. Cool. All right, and then the next one should be functions. All right, so we're good to go. Just want to make sure I have the right notes set up for you guys. Look at one more thing, 10.6. I think over here. 6, 2.5. I get that by equation of line. We can start right here. Okay, so 10.5 equation of lines. Even though we talked about slope-intercept form already, when we did last section, when we did graphing with the slopes. Hold on one second. Sorry, guys. Part of the reason why I was late, I had to do this whole thing with this building, but okay, I'm back. Sorry about that. So equations of lines, slope-intercept form, y equal to mx plus b. And like I said, we talked about this slope-intercept form last class when we did slopes and we were graphing with your slopes. M represents your slope, y is your y-intercept, b is your y-intercept. All right, so give you a chance to write that. So an exercise that they could ask of you when dealing with the slope-intercept form is to determine the slope and the y-intercept. So now notice when you go back to it, you look at it right here, what's going to be the deciding and determining factor if it's in slope-intercept form is if your equation is solved for y. And then over here, simplify as much as possible. And that means then whatever's in front of x, whatever's attached to x is your slope, and the other number is your y-intercept. So looking at this first one, if I have y equal to 3/5 x minus 2, my equation is already solved for y. And I can just go ahead and pick out what's sitting in front of x. That would be my slope, which is 3/5. And then the other number is my y-intercept. That's -2. So over here, someone that asked how would they ask it. In my math lab, they'll probably just have your slope. Then you have a empty box, you type in the number, and same thing for your y-intercept. Empty box, type in the number. All right, any problems with A before we look at B? Okay, so now B is not is not solved for y. Let me erase this just to give you the equation before we look at solving it. So we have 5x plus 9y equal to 11. So your goal now should be to solve for y. You want to put it in this form right here. Y is on one side by itself. So first thing we'll do is subtract 5x from both sides. That'll put us here at 9y equal to -5x plus 11. All right, and then we divide by 9. Then 9 we have to go into each one of the terms. Oh, see, I might erase it on. Oh no, what happened? All right, there we go. Sorry about that. But now we have to go into each term in your numerator. So it's -5x over 9 plus 11 over 9 when we break it up. And then whatever's sitting in front of x is your slope, and the other number is your y-intercept. All right, questions on that? All right. Next type of exercise you may see is let's find the equation of the line with y-intercept 0, -3, and slope of 1/9. I said 1/9. I meant 1/4. I said 1/9. Sorry about that. But same practice whether you write 1/9 or 1/4. So if you got 1/9, you can hold true to it. All right, so we're gonna take 1/4, plug it in where we see m, take that -3 because that's our y-intercept, plug it in where you see b. And that is our equation. All right, any questions before we go to the next thing? Make sure we're good. All right. So the next type of formula here that we will be dealing with, well, next time formula we'll be dealing with in this section is the point slope formula. It's y minus y1 equal to m times x minus x1. Where m, just like before, is your slope. X1, y1 would be any point on the line. So before, if you had the slope and the y-intercept, then you could create your equation. This time, if you have the slope at any point on your line, you can create your equation. So really, if you want to use your y-intercept here, you could, but. Yeah. So it tells us or asks us to write an equation of the line with slope 2 and passes through the point -4, 6. All right, so the given information over here, my slope is 2 and my point is -4, 6, so that's going to be x1 and y1. And then over here, you see that we're plugging in for x1, m, and y1. So we're not messing with x and y, but we're plugging in for x1, m, and y1. And so that's what I did right here. So y1 is 6, m is 2, and x1 is -4. Make sure you don't lose a negative. You're plugging in -4, but also there's a minus sign in the formula. So once again, make sure you don't lose a negative. All right, negative to negative turns positive. I don't know why I keep doing that. All right, negative to negative turns positive, and then we'll distribute our 2, which then gives us y minus 6 equal to 2x plus 8. Then we can finish it off by adding 6 to both sides. And the equation is y equal to 2x plus 14. All right, questions on that before we go to the next one? All right, gonna scroll up. Anybody still copying? All right, so next one, write the equation of the line with slope -2/3 and runs through the point 5, 0. Write that in there. All right, first thing we do, once again, is we recognize what our given information is. And our slope is -2/3. Our point is 5, 0. Plug those values in for y1, m, and x1 accordingly. So we have y minus 0 equal to negative 2/3 times x minus 5. Do our distribution. So of course y minus 0 is just y. Negative 2/3 times x is negative 2/3 x. But then we have negative 2/3 times 5, which is what I did over here, just to make sure we're good on those fractions multiplication of fractions. So negative 2/3 times negative 5 over 1. Just multiply across. Negative 2 times negative 5 is 10. 3 times 1 is 3, so that's just 10/3. So that's how we got this equation over here.
I have a question. For
Yep.
the fractions, you just do the top ones, like the -2 and -5, and then the 3 and 1. So you do that for all fractions?
When you're multiplying.
Okay.
Now, if you had to add them, if you had negative 2/3 plus negative 5 over 1, now you have to find common denominators, in which you change the denominator to both 3. So it'd be negative 2/3 plus negative 15 over 3. And then that would be negative 17 over 3. So it's just a different process if you're going to add or subtract. But multiplication and division, you do not need common denominators.
Okay, thank you.
Yep, not a problem. All right, any problems with that one before we go to the next one? All right, so next one, write the equation of the line that passes through -3, 4, and 5, -4. I said -3, 4, 3, 4, excuse me, and 5, -4. All right, so the difference between this one and the ones we've done prior is that we had a slope in the previous examples. This time we don't have a slope, but we do need a slope. So they gave us 2 points. I call it the first point that I saw, x1, y1, second point, x2, y2. All right. So we will use our slope formula, y2 minus y1 over x2 minus x1 to find the slope first. Slope that's created by the line that has the 2 points in it. So plug them in accordingly. Y2 is -4, y1 is 4, so that's -4 minus 4. X2 is 5, and then x1 is 3. So -4 minus 4 on top, which is -8, 5 minus 3 on bottom, which is 2. That simplifies to -4. Mm-hmm. Any questions on that before we go to the next part? Still in the same problem, but remember the first thing we needed was a slope before we can actually create the equation of the line. Mm-hmm. So now that we have our slope, and remember we have 2 points that are on the line, it doesn't matter which point we use, because both points are on the line. I decided to use the first point since I've already called it x1, y1, but once again, it doesn't matter which one we use. So back to our formula right here in the red box. Y minus y1 equal to m times x minus x1, Pointslope formula. Plug in 4 for y1, -4 that we just found for this x. I mean, not for this x, for the slope, for m. And then for x1, plug in 3. And we use this point right here, 3, 4. Once again, if you wanted to use 5 negative 4, you could. You still should come up with the same equation. All right, so distribute. Negative 4 times x is negative 4x. Negative 4 times negative 3 is positive 12. Then we would go ahead and, now let me see, standard form, blah, 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 where'd it go? Okay. I didn't write the rest of this problem. I'll write it over here. So we will add, well, is everybody okay with this before I go ahead and scroll over to the right? Okay. This problem in the book must have took us a standard form. So I'll talk about that in the purple in a second, but I just want to finish this one up. And according to the way we've done it up to this point. So y minus 4 equal to 4x plus 12. So to finish it off, we'll add 4 to both sides. And y is equal to 4x plus 16. So now this is, like we mentioned already, slope intercept form. Right. Now it's possible that they may ask for standard form, which is right here, ax plus by equal to c. And all that means is that you want your terms that are connected to your variables on one side of your equation, and the constant, the number that's not attached to a variable, on the other side of the equation. So, and that's what we ultimately did here. It's the same terms. Notice we have, okay, yeah. So notice we have 4x and y, and we have 16, but they're all on one side of the equation. Let me look at them, listen something. Yep, I'm missing, that should be negative 4x. I left this negative 4 off. So it's y equal to negative 4x plus 16. Once again, that was a negative 4 right here that I left off when we transferred the terms. So if you go to this format and they want standard form, all you would do is just add 4x to both sides. So you just got to make sure you're watching what they're asking of you. So if you were to add 4x to both sides, then that'll be 4x plus y equals 16. And that would be standard form. And when your x and y terms on one side of the equation. All right, any questions on that before we go to another problem? All right, are we good? Okay. All right, so the next one starts right here. Write the equation of the line that passes through 1, negative 1, but it's parallel to y equal to 2/3, or 2x plus 3. Sorry about that. Right? All right, so last class we talked about parallel lines and perpendicular lines, but we're talking about parallel in this problem. Talk about parallel lines, and if two lines are parallel, they are going to have the same slope. That's what I was emphasizing right here, that they're going to have the same slope. So we know what our point is. That's 1, negative 1. So that's going to be x1, y1. the slope of this line is 2. Remember, that's what's sitting in front of x. So that means the slope of a line that's parallel to it will also be 2. And that's what I was emphasizing right here. So remember, before we do these formulas or use these formulas, we do need our slope. We do need to establish what our slope is. And so this time our slope is 2 because the line that it gave us had the slope of 2 and we want a line that's parallel to it. Right? Now once we've established our slope, we were given our point. Now we can use the point slope formula. Point slope formula. Y minus y1 equal m times x minus x1. Same formula we've been using in this section. And let me erase this stuff so you see clean substitution. So that'll be y minus y1, which is negative 1, equal to 2 times x minus 1. So we're going to distribute and make sure we recognize that negative to negative is positive. So that's y plus 1 equal to 2x minus 2. And then we will go ahead and subtract 1 from both sides. Equation is y equal to 2x minus 3. So that's the equation of the line that's parallel to the one that it gave us, but runs through 1, negative 1. All right, questions. Do one more, then that'll be it for this section. Everybody good? All right, so this time, we want to write the equation of the line that passes through the point, negative 4, 2, but is perpendicular to 2y equal to x plus 7. So this time, instead of parallel, talking about perpendicular. The line we create will be perpendicular, or the equation we create will be perpendicular. All right, so before we were looking at parallel, two lines that are parallel, remember they're gonna have the same slope. If we have lines that are perpendicular, the slopes will be negative reciprocals of each other. So that's why I want to remind you right there, that slope will be the negative reciprocal. So we're gonna take the equation, what else did I erase? Yep. We're gonna take the equation that they gave us and solve it for y. So in this case, all we had to do was divide by 2. And that gives us what's in the purple box, y equal to 1/2 x plus 7 over 2. Everybody okay with that? So we have our equation, solve for y, that's what we needed. Now the slope of this equation that it gave us is 1/2. That's the number that's sitting in front of x. But if our line that we're trying to create is a perpendicular to it, then that slope has to be the negative reciprocal. In other words, you flip the fraction and use the opposite sign. And so that's what we have right here. So that's going to be the slope that we use. We're not going to use the 1/2. We're going to use negative 2 over 1, which is just negative 2. We would use 1/2 if our line needed to be parallel. But since it's going to be perpendicular, we need to flip it and use the opposite sign. Questions? Any questions? All right. All right, so let's finish it off, finish off the problem. So we're going to go back to our point slope formula. Y minus y1 equal to m times x minus x1. Use our given information. Our slope is -2, and the point that they gave us to use is -4, 2. Plug it into your equation accordingly. So that's y minus 2 equal to -2 times x minus -4. Negative turns positive, and we distribute -2, and that'll put us here at y minus 2 equal to -2x minus 8. You know that that -2 negative turns positive, so that's a positive 4 times a -2, so that's how we got -8. Then to finish it off, we will add 2 to both sides to get y by itself. So then we'll have y equal to -2x minus 6. That will be our slope-intercept form. And then here, oh, still have my eraser on. Then right here, just re-emphasizing what I mentioned before, if they want standard form, then you make sure your x term and y term on one side, your term that didn't or not associated with x or y is on the other side, are constant. It's on the other side by itself. So all I did was added 2x to both sides of the equation to get to the standard form. All right, questions on anything? All right, so we're okay. We're going to the next section. All right. So the last thing we'll talk about today is functions. Make sure I know we're going to come down here. Just taking a look at what we got. Okay. So 511, well, it'll be 10-6 for you guys. Let me make sure. Yep. 10-6 for you guys, which is functions. 4. All right, so we'll start off with the definition of a relation. So a relation is any set of ordered pairs. So example of that, 1, 2, 3, 4, 5, 6. We have 3 ordered pairs. That is considered a relation. The domain is the set of all of the first components of the ordered pairs. So if I look at that relation, I would use 1, 3, and 5. 1, 3, and 5 would be your domain. Your range is going to be a set of all of your second components of the ordered pairs, which in this case would be 2, 4, 6. Right now, we're just looking at terminology. Everybody okay? All right, so just a clean comparison. from your domain to your range, differences in the two. So your domain is your, as mentioned, domain is first components, range second components. So that means your domain will be your x variables, wherein your range will be your y. Also, your domain is considered your input when your range is considered your output. So if you think about how we've done it and did our graphs, you would choose your x values, plug in your x values, get out your y values. So you plug in your domain, get out your range. Also, your domain is considered independent. Your range is considered dependent. Your dependent variable. So your range depends on what you chose for x or for your domain. And then also your domain will be your horizontal axis, where your range will be your vertical axis. So you give you all of these ways of looking at what your domain is versus your range, just in case your variables are different. So in other words, if you don't have x and y, let's say you have s and t or m and n, these characteristics still hold true. First component, second component, input, output, independent versus dependent. Any questions on anything? All right, anybody still copying? All right, so looking at the definition of a function. Function is a relation. Once again, going back to what a relation is, just a set of ordered pairs. A function is a relation in which the elements from the domain corresponds to exactly one element in your range. All right. So elements in the domain corresponds to exactly one element in your range. All right. I still copying black. All right. So first exercise, determine whether each relation is a function. So the first one we have 1, 6, 2, 6, 3, 8, 4, 9. All right. So if you set up, let me erase this so we can walk through it. So if you set up a mapping, in other words, you have your domain 1, 2, 3, 4, range over to the right, 6, 8, 9, and then you try to just draw arrows to represent, does each one of them fit the definition of what the function is, or what a function is. So remember what a function is. Um, it says a relation in which the elements from your domain corresponds to exactly one element in the range. So you would take each one of your elements in your domain and map it out to where it goes into the range. If you can answer yes for each, then it is a function. So you look at your domain, look at number one. Does it go to exactly one element in your range? Yes. The answer is yes, because it just goes to 6. Now, the number two, does 2 go to exactly one element in your range? The answer is yes. Even though it goes to the same number that 1 goes to, does 2 go to exactly one element in the range? The answer is yes. The number is 6. Does 3? Answer is yes. It goes to 8. 4 goes to 9. So since I can answer yes for each one of my elements in the domain, going to exactly one element in your range, yes, it is a function. So like I said, even if, they go to the same element, as long as they only go to one, then it is a function. Any questions? All right. Are you okay? And that's not it. Okay, here we go. So the next one we have 61, 62, 83, 94. And we would do the same thing. We want to create a mapping of our domain to our range, look at each individual value in our domain, and then ask ourselves, does it go to one value in the range? And if there's one value that does not do so, then it is not a function. All right, so we have 6, 8, 9, 1, 2, 3, 4 in the range. We look at our 6, notice 6 goes to 1, but also 6 goes to 2. So no, it does not go to just one value in the range, which means it is not a function. All right. Problems with that before we yeah, we got a few general statements, but I want to make sure that everybody's copied it.
Can I see the first example again?
Yep. Everybody good with this one before I scroll up?
Hold on 1 second.
Yep.
All right, we good. Thank you.
All right. So here's that first one.
Okay, I got it. Thank
Yep, not a problem. All right, so just some general statements about how you can look at determining what a function is and what isn't. So there can be a repeated value in the range, but no value can repeat in the domain. And I'm gonna scroll back up, but I just want to show you what I mean. So it was a function when we had 6 repeated in the range, but it was not a function when we had 6 repeated in the domain. So that's what I'm talking about when you say that. So there can be repeated value in the range, but no value can repeat in the domain. The range can go to more than one value. The domain can only go to one value. All right. All right, is everybody good? I think there's one other thing out of this section. Oh, is that it? Oh, here you go. All right, so function notation. So get ready to close out this section. Close it out with function notation. y equal to f of x. And that's what I was writing right here. When you see f parentheses x, that's f of x. That's how you say that. Same things if you had, you look down here, g of t. G parentheses t is g of t. It's a darker purple. So the way you write a function in function notation, it just says that y is equal to f of x. That means those two symbolisms can be interchanged without any problem. So notice I have y equal to 2x plus 1. I can switch out f of x for y. And the functions, the equation would still be the same. It's just that now it's in function notation. F of x equal to 2x plus 1 is function notation. So the reason why you would use function notation is if, let's say if they tell us to find f of 3, f parentheses 3. And the reason why I had it scribbled at first is because even if they does not say find, if all you saw was f parentheses 3 and you wanted to know what it was, you would know what to do. What it does is it tells us to take 3 and plug it in where I see x in the equation. So remember, it was f of x, but now it's f of 3. So that's just telling me that whatever my function is, take x and substitute 3 for it. And so since f of x is equal to 2x plus 1, I plug in 3 for x. 2 times 3 is 6. 6 plus 1 is 7. So I plug in 3, got out 7. So also, as an ordered pair, that lets me know what my ordered pair would be. X would be 3, y would be 7. All right, any questions? All right, so first exercise under this thought process, given that g of x is equal to x squared minus 5x plus 7, and they will define what your function is. They can't say find g of 0 and not tell you what g of x was. So they give us our function to be x squared minus 5x plus 7, and then tell us to first find g of 0 and then find g of negative 2. So g of 0 just means I'm going to plug in 0 for x. And then g of negative 2 just means I'm going to plug in negative 2 for x, wherever I see x in my function. So that's what I did here. X appears twice. I have x squared minus 5x plus 7. 0 squared minus 5 times 0 plus 7 is what I have now. 0 squared is 0. 5 times 0 is 0. So that leaves me with 7. And so that ordered pair would be 0, 7.
I have a question. What would you do with the negative 2?
Oh, that's B. That's a different problem. Yep. So since he went there, that's where we'll go. And so for the second, for B, you're taking the same function though, because you're still dealing with the function g of x. And then you plug in negative 2 where we see x, just like we did 0. So negative 2 squared minus 5 times negative 2 plus 7. So negative 2 squared is 4. So that's negative 2 times negative 2, which is positive 4. Negative 5 times negative 2 is positive 10. And add those together, that's 21. All right, any questions? All right. I think this is the last thing out of this section, I believe. So, want us to find the domain. So they give us f of x is equal to 1 over x plus 5. And so when we look at the domain, got these few notes. So we want all the values that can be used used in the equation for x. Or in other words, all values that can be plugged in for x. So in other words, in certain situations, you'll see as we look at these type of examples, certain values you cannot use depending on the type of function you have going on. So, and that's what I wrote right here in the dark purple, look for the values that you cannot use first. So you look for the values that you cannot use, and then from there, you'll know what you can use. So what do I mean by that? In this case, a fraction cannot have 0 in its denominator. All right. So anything over 0 is undefined. So a fraction cannot have 0 in its denominator. So the rest of that, try to give you all of this. Yep. So when is the denominator equal to 0 is what we have to ask ourselves. Whenever dealing with a fraction, you want to know when is the denominator equal to 0 so that you'll know what values you cannot use. All right, can I scroll up and the rest of the copy? All right. So I want to know when is my denominator equal to 0. So to find the domain of a rational expression, in other words, a fraction, it's another word of calling a fraction, another word for a fraction, rational expression, another expression for a fraction, rational expression. You're going to set the denominator equal to 0 and then solve it. So we're going to take x plus 5, set it equal to 0, and solve for x. So subtracting 5 from both sides, x is equal to -5. So now this is the value that cannot be used because this is when the denominator is equal to 0. And remember, our denominator cannot be equal to 0 because that's when our fraction is undefined. All right, so once again, that -5 cannot be used, but everything else can. So our domain, writing our domain in interval notation, that's -infinity to -5. Use our union symbol. This is our union symbol. Then -5 to +infinity. Notice you use parentheses on the -5, not brackets. Brackets mean that you can use -5, so you do not use bracket, you use parentheses. All right. Questions on what I've done up to this point? All right, can I scroll up? All right, so for the next one, we're looking at g of x is equal to 3x minus 1. And I should have put a what right there. What are the values of x that I cannot use? So we're looking at g of x equal to 3x minus 1. Just like before, we're asking ourselves, what are the values of x that I cannot use? In this case, or in any case, is there something I can plug in for x to make the equation undefined? Before it was -5. That's where, what value can I plug into this equation, though, to make the equation undefined? So now in this case, the answer is, let me see, I said what? Okay, I see what I did there. So what I was actually trying to say, are there values of x that I cannot use? So that should have been up there. Just trying to tighten up my notes a little bit. But anyway, are there values of x that I cannot use? Only reason I'm saying it because of the way I answered this. But in this case, the answer is no, there is not a value for x that will make this undefined. So there's nothing I can plug into this equation right here to make it undefined. Just by the nature of what it is. It's not a fraction. It's not a square root. I don't think you guys are going to get square roots. Let me scroll up a little bit. Yeah. So you guys aren't going to have to deal with square roots. So it's not a fraction. So I know I can't get 0 on the denominator. It's not a square root. So I don't have to worry about taking the square root of a negative or anything like that. So there's nothing that really I can plug into this equation to make it undefined. So my domain will be -infinity to infinity. That just means that all values can be used. I can plug in anything into my domain or into x. I can plug anything into x and get out a value. All right, questions? Any questions? Now, the last thing in this section, I believe they show you some graphs and ask you to find the domain and range. Let me erase this, but then I'll put it back. We'll just see what the actual problem is. So it says find the domain and range, and then they give you this graph right here, where that point to the left is -3, -1. Point to the right is 4, 5. And we have this line segment, have these endpoints. All right. All right, so just reminding you with the little notes that your domain or your x values. And when we look at trying to figure out what our domain is, we're talking about going from left to right, that extension of our graph. How far left and how far right can I go? My range would be my y values. How far up and how far down can I go? So that's what's going to determine what your domain is and what your range would be. So if you look at our range, let's go domain. The furthest we go is -3 to the left, and then to the right would be 4. So that's why we have -3, 4 for our domain. Now we can use these points, so that's why we have brackets. Notice the points are solid, so that's why we have brackets. If they were open circles, then we would use parentheses. And then as far as your range, and I wrote that note right here in the purple box. And then as far as your range is concerned, how far down do I go? That's -1. That's my y component of my ordered pair. Then how far up do I go? That would be 5. So once again, your domain goes from left to right. Your range goes from down to up. Any problems? Any problems? All right. Last one. So get rid of this red. So your domain and range for your parabola. We have a parabola here. It's a U-shaped. So notice I said that my domain is going to go from negative infinity to infinity. So what we're talking about here is, once again, left to right. That 3 doesn't matter in this case because that's your x. Your x is going to be left to right. So how far wide how far to the right and how far to the left does it go? Well, as you continue to go up, it's going to continue to get wider and wider. And that's going to go to infinity. As far as you go up, it continues to get wider and wider. And so remember, your domain is always how far left and how far right do you go. So that's why whenever you have a parabola, it's always going to be negative infinity to infinity. All right, questions on the domain of your parabola? All right. Now, it's how far up and how far down and how far up does it go? Now, as far as down, this is our point, our lowest point, and the coordinate of that would be -2. So that's why we start with -2, and then it goes up to infinity. So those arrows say it's going up, and so that's why we have infinity right here. Once again, you always use parentheses on infinity, not bracket. All right. Questions? Any questions? Any questions on anything previous to this section?
Yeah, I got 2 questions. So the homework today is up to 10:06, right?
Yes, I was gonna go there, show you guys this just to make sure we're clear.
And another question real quick. I haven't emailed the guy about the test yet. How long do we have to do that?
When you say how long, you talking about how long during one sitting, or when should you take it?
How long do we have to take it?
Okay, well, really, it's open till the end of the session. So the thing about it is, you should knock it out as soon as possible.
Okay.
Because the further we go along, the more you're gonna have in the back that you need to get, caught up. So you don't want to have a whole bunch of stuff thrown on top of you when you have, stuff that you could have done in the past, and you want to knock that out and be able to put that behind you and move forward. So that's the thought process you want to get to, and that's why I was going to make sure we understand where we are as far as your assignments are concerned. Um, we have our first block, and I can't write on the screen, but our first block of homework was done 9-6, when we did that first block. Then we jumped into 10-1 through 10-6. So now this closes out our second block of homework, which means we have 2 tests out there that you guys are, held responsible for. So, you guys want to get on that first test as soon as possible. I know a few people have taken it already, so, good job on that. But what you don't want to do, like I said, is have all of this content out there, and you haven't started knocking out these tests. So you want to do those as soon as possible, so that you can get these tests under your belt and actually move on and move forward. Any other questions on that before I say something else? Everybody good? Everybody straight? So once again, we just finished 10-6. So now we have 2 tests that we have to get, that we have to take care of. What I probably will do is offer, let me look at my schedule. If I don't say anything about it next class, make sure I mention it. For those who want to take advantage of it, it's offer a test opportunity on Friday, probably Friday at 10. For those who haven't taken the test yet, you want to come in and take the test with me, then feel free to do so. The opportunity is always available for you to take the test with Mr. Davis if you don't want to wait till Friday. But I think somebody unmuted, Mr. Hudson.
So that would be the first test to be
It
taken
doesn't
on
matter.
Friday?
It doesn't matter. Whatever test you want to take. If you've already taken the first test and you want to take the second test, you can do it. Basically, I will give you the password for whichever test you come in and say you're ready to take.
Okay,
Yep.
thank you.
Yep, not a problem. So that would be, whatever I offer those days. That's a great question. Whenever I offer those days, it doesn't matter where you are. What will happen is you log on. You let me know what test you want to take, and I'll give you the password for that specific test, and then you would, go ahead and take that test. Don't forget, whenever you take a test, you enable your camera, show your ID to the camera, and then you leave your Zoom camera on, even though you may go to another screen to go to my math lab, but you leave your Zoom camera on and stay, linked into a Zoom throughout the whole testing period. All right. Any other questions on that? Everybody good? So once again, like I
Any
said,
specific
go ahead.
any specific time on Friday?
Well, I'm thinking 10 o'clock. That's why I said that's exactly what I was about to say.
Okay.
If I forget to mention this on Wednesday, make sure somebody bring it up. If you want to take advantage of a Friday, test taking, make sure I do talk about it before we leave on Wednesday. Yep.
Okay, thank you.
Yep, not a problem. All right. Anything else? Anybody else? Everybody good? Okay. Any questions on anything else? Like math questions? Everybody good? Everybody straight? So next class, I will most definitely open up the floor for questions first before I go anywhere else. So it will be an opportunity to go into my math lab, see if you have any questions, try some problems out. Even if it's just picking out some problems you want to see me do. I will open up the floor first for you guys to ask whatever questions you want to ask out of the first block of homework, second block of homework, whatever. And then we'll go from there. All right. So if you guys are good, I'm good. Thank you for your patience in the beginning of the class. Like I said, I had that unexpected thing that I had to deal with. And I will see you on next class. All right. You guys have a good one.
Thank you.
Thank you.